Okay, more probabilities. Now that we have combination notation to help us, they can start ramping up the difficulty of the problems, and let's see if we can keep up. So, 5 cards out of a standard deck, and when you look at the cards, what is the probability that you get 4 aces? Well, all these probabilities are going to be out of 52C5, because that's how many different things can happen if you have 52 cards and you select 5 of them. Now, the numerators are where the work is going to be. How many hands are there which contain 4 aces? And, of course, because this is a 5-card deal, there must be one non-ace in here, too. So, there are 4 aces, and you got all 4 of them. Also, there are 48 non-aces, and you got 1 of them. Now, do you see any way we could shortcut this? Are there any combinations there that you just know? 4C4, if you work it out, what do you think? If there's 4 things and I say, here, take all 4 of these, how many ways can you do that? Calculator says 1. Anytime you have 3C3 or 10C10 or 85C85, that's just a 1, so you can pretty much ignore it. It means if there's 4 things and I'm saying you must take all 4 of these, you really don't have any choice. There's only one way you can do that. Now here's another one you can eyeball. What's 48C1? If you have 48 objects and I say select one of these, amazingly enough, there's 48 ways to do that. You're just picking one of the objects. So those two are kind of trivial combinations. 52C5 is not trivial at all. 52, math left, 3, 5. 2,598,960. So overall, our probability would be 48 times out of basically 2.6 million is your chance of getting all 4 aces on a poker deal. How about 4 tens and an ace? Same denominator as before, 52C5. Now, the chance of 4 tens is the same as 4 aces or 4 fives or anything else. It's 4C4. Or I shouldn't say the chance. The number of ways you can get 4 tens is 4C4. Now, they're specific about this card. It's not just a non-10. It has to be an ace. So for this we have, there are 4 aces, and you can take any one of them. And our denominator is the 52C5. All these problems, they're asking for the probability and combination notation, so I'm not going to bother crunching this out to a fraction anymore. I'll just stop at this point. Okay, so 4 tens means there are 4 tens in the deck and you get all 4 of them. Aces, there's 4 in the deck, you get 1. And the overall number of possibilities is 52C5, which means 52 cards in the deck, you get 5. Okay, a 10, a jack, a queen, a king, and an ace. These are all 5-card deals, so that part keeps showing up. Tens. There are 4 tens in the deck. You get 1 of them. Jacks. There are 4 jacks in the deck. You get 1 of them. Queens. There are 4 queens in the deck. You get 1 of them. Kings. I'm sure you get the idea. And aces. It happens 1 more time. So for all of these 4 versions of that card in the deck, and you get to select a single one to go to your hand. Now, at least 1 jack. At least 1 is a fuzzy value. That means we could have 1 jack plus 4 non-jacks, or we could have 2 jacks and 3 non-jacks, or we could have 3 jacks and 2 non-jacks to make our 5-card hand, or we could have all 4 jacks and a single non-jack to fill out the hand. Are you excited about crunching all that out? Because I'm kind of not. You could totally do this. It would start out 4C1 times, there are 48 cards which aren't jacks, so 48C4 plus 4C2 times 48C3, and so on, and then you could add all those up and try to simplify the result. Is there another way to do at least one? Yes, there is. The other way is, what's the opposite of this? What's the complement of I got at least one jack? The complement of this is I didn't get a single jack. No jacks at all. What's the probability of getting no jacks at all? That would mean there's 48 cards in the deck which are not jacks, and you got 5 of those out of 52C5. This is the probability of getting no jacks whatsoever. 1 minus that would be the probability of getting that you didn't get 0 jacks, meaning you got 1 or 2 or 3 or 4. So this is the elegant way, and in case you don't think of the elegant way, no problem. The brute force method is going to work. It just takes you a little more time.